Hello and welcome to the Rapid Eye Vision Measuring Systems. It's a multifunctional vision system that can do all that a profile projector, a toolmaker's microscope, a vision system, a CMM, a 3D scanner, and a contour tracer can do all in a single machine. Extremely simple to use, as we will see in this video. This is the standard model of the Rapid Eye Vision system. That's the optics in the camera system. And we can zoom in to see the XY workstage, which is encoded at 0.5 microns, on which we place the component on the workstage. Then we move the Z-axis to focus, and that's the general software interface that you have with the different aspects of the software. You zoom in to from 11x to 67x magnification. You have a software controlled zonal lighting system. You just have to click and scroll the lighting rings to choose each of the zones that you would like. And based on the zones of lighting that you do, the same component looks different. For example, he's switching on zone 2 that comes from the right side. So you can see when he switches on from the bottom side, the bottom of the beak gets illuminated better. So you can illuminate the component the way you like. You can lock all the 4 zones and switch on the complete ring of lighting to the same intensity. Once we have illuminated the component, we are ready to generate the geometry. To do this, we have a cutting edge tool called Fast Trace, which will by default draw a straight line. If I want an arc there, I just right click, move my mouse and click on the edge. It becomes an arc, and the end point of the arc becomes a start point for the next line. And then I just click and I left click and I right click and construct the outline of the component that I would like to measure. So we can carry on like this to construct the complete drawing, and you can see that the drawing gets ready in the RapidCAD window on the right side of the screen. Once the drawing is ready, we are now ready to do the measurements. To do the measurements, just maximize the RapidCAD window, and you can zoom and pan just like you can in any CAD software. Switch on the measurement mode, go close to the arc, double click and you get its radius. You want the angle, click on the line and click on the other line, and it automatically gives you the angle between them. Pretty simple, straightforward and intuitive. So if you want the point-to-point distance, click on the point, you get the geometric distance. If you want the X and Y shift for your CNC programming, choose the same 2 points in the linear mode, move your mouse to the left or right, you get the Y shift, and move it up or down to get the X shift. Once you're happy, click to fix it. If you want the diameter, double click on the circle and you get the diameter. So to generate a report in Excel next, it's extremely easy. If you want the reports to be in inches mode, just go and click on the inches mode on the top of the screen, and all the measurements goes down into the inches mode. Click on the data transfer to the Excel button, give a name to the report you like, and click on save. That's it. Your report gets ready automatically from a pre-formatted template. All your measurements that you did are automatically written in Excel with the date and time, and you can put your company logo in it. We will next see how RapidEye easily and seamlessly integrates CAD tools into the measurement process. The drawing we generated for doing the measurements can be exported as a 1:1 DXF. So just click on export button, give a name, and the DXF is ready. You can open that in any CAD software that supports the DXF format, and you can do further editing and other processes that you would like to do over there. Now consider this drawing was your original design drawing, and you have actually manufactured your component. You want to see how good your manufacturing is. You can import the drawing, take 2 points as reference on the drawing, and take the same 2 points in the component, and the drawing gets aligned. As you can see, it floats with the mouse. Move the mouse carefully and click to fix the drawing. Now you're not very satisfied with the alignment. You have a nudge tool. Just click on it. You can type in steps of 5 microns, 10 microns, 20, whatever you like. Use the arrow keys in the keyboard, and you can do a fine adjustment of your drawing to the component. Once you're satisfied, you can switch off the nudge mode. You can visualize the deviations of the manufacturing with respect to the original design. Now you want to quantify that. Just switch on the digital micrometer, go close to the drawing, click on it, it snaps, and you get the distance, the gap immediately on the screen itself. So you can now visualize and quantify exactly what the deviation is. Further, I can add some comments to the image by just clicking the Fix Text tool, typing in the comment I want to add. I can add the date and time as well, and then place it wherever I like, change the color, the size of the font I would like. By just rolling the mouse, the size changes, and click to fix wherever I want on the video. Once I've done this, I click on Save the Image with the graphics on, image of the component, the drawing that we overlaid, the measurements we did, and the comments get saved in a single JPEG file. You can email this to your customer or supplier, and there will be no confusion as to what the measurement that's happened. We can next go and see what we can do in 3D. So if you want to measure the depth of the emboss of the eagle, just click on a point on the eagle's beak and one point on the base of the nearby the eagle, and then click on the video. It scans in the z-axis, and you can see on the bottom left it evaluates in real time what's the level of the focus. So as the focus happens, it calculates the best z position for the two boxes. The difference in the z positions of the two boxes gives you the depth of the emboss. So you can measure the depth in this type without touching the component or cutting it. We can now scale the number of boxes into a grid and do a complete non-contact 3D scanning of the component. So once one frame is done, it moves to the next one, and you click on focus again, and it focuses and takes as many points as it can get. You can now do the scan at any density that you would like, maybe even 3 microns every point. So you can do it at any scan, at any area that you would like, and you can switch on the 3D mode and see your cloud points like this. You can export it as a DXF or as an STL file. Here is an example of a DXF of a fan that is used in our desktop computers, scanned in rapid eye, shown in 3D. So you can take it to any 3D software that will reverse engineer this into surfaces or 3D models. Here's an STL file of a simple tablet. We will next see how we can use profile lighting, that is lighting from the bottom, to see different features and measurements. Here you see a simple tool insert. You can see the chip offs and other things, and when you switch on the profile light from the bottom, you see the perfect shadow, sharp and nice. So in this we want to measure a simple angle and a corner radius. Choose the angle tool, click and click. You get an automatic edge detection within the blue box, and it's taken about 500 points. Done the best fit. You go to the end of the straight edge, click again to define another region of interest, and the line gets automatically extended. Once we are ready for the next line, we just right click and click again to generate the next box. The moment the two lines are done, the angle measurement comes up automatically. So you click to extend it, the angle updates itself, and you're done with the angle measurement. To do the corner radius, go to the corner radius, click at the start of the arc, end of the arc, and change the direction and click, and the radius comes up automatically. The software has been recording every step we have been doing. So click on the build, give a name to the program that you would like, and then just click on build. It makes a part program for you. To do repetitive measurements, we can go and recall the part program. Go to the home position of the component, switch on the CNC mode, and click on Run. So the machine goes automatically from the first to the next step, and it does the point picking and updating the measurement automatically, and writes all the results to the Excel. Once it's done, it says it's over. goes back to the home position, ready for the next one. Put the next one in, click on run, and then watch as the measurement is completed. You can click the report button and take a look at the Excel report that has been automatically generated. RapidEye comes with a comprehensive set of tools for generating virtual geometries. For example, you can generate an angle bisector, that is a midline between two non-parallel lines. You can extend it to be an infinite line. You can measure the distance of the center to this angle bisector. You can also draw parallel lines, perpendicular lines through a particular point. Here we are drawing a perpendicular line through the center of the arc. We can draw a line parallel to this line with an offset of, let's say, 2 millimeters, and click to fix it, and then you can generate the intersection point of these two lines. The final feature in this video is going to be the CMM functionality built in with Renishaw touch probe integrated with RapidEye. Here you see a standard Renishaw TB20 touch probe doing a cylinder measurement on a simple ring gauge. As you can see, it moves in, touches, and the same thing is shown in the software as well. As it keeps taking point, the features are being developed and the measurement can be done completely. These are just a simple overview of some of the features that are available in RapidEye. Do not hesitate to contact us to get a live demo or to find out how we can do your component in RapidEye.